back again. Today we'll be discussing about the cancer cell classification using Scikit-Learn, a Python library. First of all, what is machine learning? Machine learning is a subfield of artificial intelligence that gives systems the ability to learn themselves without being explicitly programmed to do so. Machine learning can be used to solve many real-world problems. Let's classify cancer cells based on their features and identifying them if they are malignant or benign. We'll be using Scikit-Learn for a machine learning problem. Scikit-Learn is an open source machine learning, data mining, and also data analysis library for Python programming language. So coming to the data set we are using here, sklearn, that is Scikit-Learn, comes with a few small standard data sets that do not require downloading any file from any external website. The dataset that we will be using for our machine learning problem is the breast cancer Wisconsin dataset, diagnostic dataset. It consists of several data about the breast cancer tumors along with the classification labels that are malignant or benign. It can be loaded using the function load breast cancer. Simple. The dataset contains 569 instances, that is the tumors, and include 30 attributes of features like radius, perimeter, area of a tumor, etc. We'll be using these features to train our model. So first we need to install the necessary libraries. I'll show you it here, like pip install sklearn, pip install numpy. For current, these both are enough for now. Let's install them. Requirement already satisfied. Okay, yeah, it's downloading the packages. Perfect, downloaded. Now we need to import the libraries. First, this is the step one in any machine learning project, is to import the necessary modules and datasets. We will be needing the Scikit-Learn module and the breast cancer Wisconsin dataset. So let's import sklearn, that is Scikit-Learn, and also let's import from datasets, that is from sklearn.datasets. Let's import load breast cancer. Perfect. So let's run the cell. Okay, perfect. So we have imported. Step 2 is loading the dataset into a variable. So will be loading the load breast cancer into a variable named as data is equals to load breast cancer. Perfect. Let's run the cell. Okay, perfect. And then the important attributes that we must consider from the dataset are target names, that is the meaning of the labels, and the target, that is the classification labels, and the feature names, that is meaning of the features, and finally the data, that is to learn. So coming to the step 3, we are organizing the data and looking at it to get a better understanding of what the dataset contains and how we can use that data to train our model. Let us first organize the data and then see what it contains by using a print function. Alright guys, so let's check the label names, that is label names is equals to data of target names, and also labels is equals to data of target. Perfect, as simple as this. Then we also have the feature names. Feature names is equals to data of the feature names itself, feature names. Okay, and also let's get the features, that is the data. Features is equals to data of data. Perfect. So let's run the cell. Okay, sorry, target spelling it's T not R. Okay, so let's run the cell again. Perfect. Now let's check them using the print function. First let us print the label names. So you can see malignant and benign. Each dataset of a tumor is labeled as either malignant or benign. Okay, now let's check the labels. Print labels. As we can see here, a lot of zeros and 1 values. Here each label is linked to a binary value of 0 and 1. Here 0 represents malignant tumor and 1 represents the benign tumor. And also let's print the feature names. Okay, Yeah, here we can see all the 30 features of the attributes: mean radius, mean texture, perimeter, area of the tumor has. We'll be using the numerical values of these features in training our model, and we'll be making the correct predictions whether or not a tumor is malignant or benign based on these features. And also let us print the, what is the left one? Features, print features. Oh, again, sorry, again I printed the feature names. Let's print feature. Is it feature or features? It's features. Yes. Yeah. So this is a huge dataset containing the numericals of value 30 attributes of all 569 instances of human data. So from above data, we can conclude that the first instance of tumor is malignant and it has a mean radius of value 1.799 E plus 01. Already, yes. So next, the step 4 is we'll be organizing the data into sets. For testing the accuracy of our classifier, we must test the model on unseen data. So before building the model, we'll split our data into two sets: training set and testing set. We'll be using the training set to train and evaluate the model, and then we'll be use the trained model to make predictions on the unseen test set. The sklearn module has a built-in function called train test split, which automatically divides the data into these sets. We'll be using this function to split into data. So from sklearn.model selection, from sklearn.model selection, we'll be importing the train test split. Import train, it's train, test, and split. Then we'll be dividing the data into train, comma, test, comma, train labels. It contains the labels and also the test labels. Test labels is equals to, so it's train test split, not train. Okay, it's equals to train test split of the features that we have given, that is the data, and also the labels we have given. And we can also give the test size as 0.33. That is 33% of the data will be in the test data set, and remaining 67% of the data will be in the training data set. And also we'll be giving random state is equals to some any number like 42, just to fix the random state of it. So let's run this one. Perfect. So now the training test split has randomly splits the data using the parameter test size. We have given split 33% of original data into test data set. The remaining is a training data set. Also, we have respect to labels for both the training variables and testing variables. That is train labels and test labels. And then coming to the step 5, building our machine learning model. So there are many machine learning models to choose from. All of them have their own advantages and disadvantages. For this particular model, we'll be using the Naive-Bayes algorithm. It is a probabilistic algorithm, uses probability. It usually performs well in binary classification tasks. Firstly, we will be importing the Gaussian NB module and initialize it using the Gaussian NB function. Then train the model by fitting the data into the data set using the fit method. So first let's import it from sklearn dot Naive-Bayes. Is the spelling right? Yes, it's correct. We'll be importing the Gaussian NB algorithm, Gaussian NB, and let's define our model as GNB is equals to Gaussian NB. Gaussian NB. Perfect. Then we'll be creating our model which contains the data that is equals to GNB. Sorry. So GNB of we'll be fitting the data into it. Fit, train, and train labels. So we are training our model with both these values, with the train and the train labels. Perfect. So next we'll be just running the cell. Just a second. Seen an error. Cannot import name from sklearn.Naive-Bayes. So is there any syntax mistake here? From sklearn.Naive-Bayes import Gaussian NB Oh, it's this spelling mistake. It is GAU. Sorry, Gaussian NB. Okay, perfect. Yeah, perfect. So after the training is complete, we'll be using the trained model to make predictions on the unseen test data set that we have prepared before. To do that, we'll be using the built-in predict function, which returns an array of prediction values for the data instance in the test set. We will then print our predictions using the print function. Okay, so let's store the predictions in the predictions variable is equals to gnb dot predict the test data set we have used here. Test, it is GNB, sorry, Gaussian NB predictions. Okay, perfect. Oh, sorry, it's predict, not predict 9. So many typos. Sorry for the typos. Okay, perfect. After the predictions, let's print the predictions. Print predictions. Yeah, so you can see from the above output, predict function returned an array of zeros and ones. These values represent the predicted values of the test for the tumors, that is either malignant or benign. Step 4 will be evaluating the accuracy of the trained model. As we have predicted values now, we will evaluate our model's accuracy by comparing it with the actual labels of the test set. That is, we have predicted the test here, and we also have the test labels. So we'll cross verify our test labels with it. Here also we have a built-in method named as accuracy score. Let's import it from sklearn.metrics. From sklearn.metrics, metrics. Let's import accuracy score. Perfect. And let's print accuracy score of test labels. That is the actual labels and the predictions we have made. So let's run the cell and see. Wow, we got 94% of the predictions right. That's really great. So our machine learning classifier based on Navier-Bayes algorithm is 94.14% accurate in predicting whether a tumor is malignant or benign. So I'll again tell you the steps what we have done here. First, we have imported the necessary libraries and the data set, and we have stored them in according to the names like the data and the data labels, and we have studied the data like using the label names. Then we have splitted the data into training and testing sets of test size 0.33, and then we have made our own machine learning model of Gaussian NB. Then we have predicted the test data set, and we have printed the predictions, and we have checked the accuracy score of our model, Gaussian NB model. It has a 94.14 accuracy, which is a very good accuracy. So hope you guys have enjoyed the session and understood how to classify the cancer cells, whether it is malignant or benign. Thanks everyone.